Hello, and thanks again for joining me. Today I'm going to just go through the answers to the questions I left in my previous video about capacitors. If you haven't seen that yet, go and check that out. There's a basic overview about capacitors and the energy stores in capacitors. And I've left 4 questions at the end for you to answer yourselves based on that knowledge. This video, I'm going to go through those questions and those answers. So here are the questions. What is the capacitance of a capacitor which stores 2 coulombs of charge for every 100 volts applied to it? Number 2, a 0.01 farad capacitor is charged by and then isolated from an 8 volt power supply. Calculate the charge stored. And then the capacitor is then connected across another identical capacitor which is uncharged. Describe and explain what will happen to the charge on each capacitor. Question 3. How much energy is stored on a 50 microfarad capacitor which is charged to 12 volts? Question 4. A 1200 microfarad capacitor is connected to a voltage supply until fully charged with 10.8 millicoulombs. If this capacitor is then disconnected and reconnected across a 10 watt light bulb, how long could it light the bulb for? If you haven't had a chance to go through these questions yet and try them for yourself, please pause the video and do try. Then we'll go through the answers together. So question 1, nice and simple. What is the capacitance of a capacitor which stores 2 coulombs of charge for every 100 volts applied to it? So we use the capacitance equation. Capacitance is equal to charge divided by potential difference across it. So in this case, we've got 2 coulombs, that's our charge. Our voltage is 100 volts, so it's simply 2 divided by 100, which gives 0.02 farads, and that's it. It's that simple. It's use the equation, substitute, and then give the answer and the units. Standard EDEXCEL method, E-R-S-A-U. E equation, R rearrange. In this case, we don't need to rearrange. S substitute, A answer, and U units. So question 2. A 0.01 farad capacitor is charged by and then isolated from an 8 volt power supply. Again, we're going to use our EDEXCEL method. C equals Q divided by V. Capacitance is charge divided by voltage. That's our equation. We need to rearrange this time, so we're going to use Q equals CV. Charge is capacitance times voltage. And then we just substitute again. Our capacitance is 0.01 and our voltage is 8. 0.01 multiplied by 8, which gives you 0.08 coulombs. So that's 80 millicoulombs. The capacitor is then connected across another identical capacitor, which is uncharged. So the key here is they are identical capacitors. We've isolated it from the 8 volt power supply. One capacitor is fully charged. It's now connected to an identical uncharged capacitor. Describe what happens to the charge on each capacitor. So what's going to happen here is the charged capacitor is going to now charge the uncharged capacitor. The electrons on the negative plate of the charged capacitor are now going to start to flow towards the uncharged capacitor. So the charge is going to flow from the charged capacitor onto the uncharged capacitor. Now you've got to remember that the flow of charge is going to stop. So in this case, we've almost got the same situation when we have a power supply and a capacitor, but the charged capacitor is now acting as the power supply. So the flow of charge will stop when the potential difference across each capacitor is the same. Just like if we had a power supply, if we have 8 volts on the power supply, then we're going to charge the capacitor until there's 4 volts across it, and then it's going to stop. This is the same here, but now it's going to have half the original charge because we can only discharge the capacitor to half the level, because as soon as it's discharged half, the other one is fully charged. So this gives us 0.04 coulombs, resulting in a potential difference of 4 volts across each capacitor. So question 3, how much energy is stored on a 50 microfarad capacitor which is charged to 12 volts? Again, we're going to use EDEXCEL to calculate this question. So energy is a half times charge times voltage. That's our equation. We know the voltage, but we don't know the charge. We know the capacitance. So we're going to need to rearrange. So we use rearrange, we use this equation, energy is a half times capacitance times voltage squared. That's because the charge is equal to the capacitance multiplied by the voltage. We've just substituted that back in. Now we substitute the numbers in. Our capacitance is 50 times 10 to the minus 6 farads, and our voltage is 12 volts. So we have 0.5 times 50 times 10 to the minus 6 multiplied by 12 squared. And this gives you 0.0036 joules. Okay? So 3.6 millijoules. So that's not a lot of energy. That's quite a small amount. And now we get to the slightly tougher question. A 1200 microfarad capacitor is connected to a voltage supply until fully charged with 10.8 millicoulombs. If this capacitor is then disconnected and reconnected across a 10 watt light bulb, how long could it light the bulb for? So again, we have to work out how much energy is stored in this capacitor. So we do the same thing again. We use EDEXCEL. Equation is E equals a half QV. We have to rearrange because we know the capacitance and the charge this time. So we don't know V. So we're going to use the fact that V is Q over C to give us energy as a half times Q squared divided by C. So charge squared divided by capacitance. So we substitute our numbers in. Our charge is 10.8 times 10 to the minus 3, all squared. And then the capacitance is 1200 times 10 to the minus 6. And this gives us a minuscule 0.0486 joules. That's 48.6 millijoules. I think I got that wrong in my previous one, but never mind. So that's 0.0486 joules. So how long could this light the light bulb for? Remember that 10 watts is the power. Watt is the unit of power. So power is energy divided by time. So that's 10 watts is 10 joules per second. So this light bulb consumes 10 joules every second. So looking at the amount of energy we have in our capacitor, the answer is going to be much less than a second. It's always good to sense check and expect the kind of answer that you're looking for, because if you've made a mistake in a calculation somewhere and you just blindly accept an answer without thinking about it, you're going to lose marks. But if you look at this and think, what does this equation mean? Power is energy divided by time. That's 10 joules per second being consumed by this light bulb. I have much less than 10 joules. It's going to be the time that I'm going to get from this capacitor is going to be much less than 1 second. We rearrange this to give us time equals energy divided by power. This then is going to be 0.0486 divided by 10 watts, which gives us 0.00486 or 4.8 milliseconds. Okay, so it's a really good idea to sense check everything that you do. So that's those 4 questions. Double check your answers against what we got. Hopefully you got them all correct. If not, go back, find out where your mistakes were and see if you can correct them. We learn more from our mistakes. Right, stay safe everyone, and see you soon. Thank you very much for watching. Bye.